Hello and welcome back. There are a few things that might go wrong or that are not allowed to do in asynchronous programming. One of such thing is that we cannot create multiple concurrent event loops. In this program, we have run function being called here. It creates an event loop. And what if we try to create another event loop within the main function, which is a coroutine? Run and directly call the long task. Let's say ID 5. Let's try to execute this now. Yes, this one. And you see that it fails with a runtime error that asyncio run function cannot be called from a running event loop. This is because run function tries to create another event loop, which is not allowed. Another possible mistake is to miss the await keyword when calling the coroutines. Let's remove this and let's see what happens if I call sleep function without await. It is asyncio sleep, which is a coroutine. So let's see what happens in this case. So as you see, the whole function finished within in 0 second, which is an unexpected result. It should have taken at least 2 seconds, um, as the sleep is 2 seconds. Because we haven't used await, it means that this function call has resulted in only the creation of a coroutine, but the coroutine didn't actually start executing. Therefore, the tasks just completed as soon as they started, and overall execution time remained 0 second. One of the most challenging issues that we may face in asynchronous programming is to block the event loop. How can we block the event loop? Well, we can do that by calling a blocking function within a coroutine. If we do so, the event loop thread gets blocked for the time of execution of that blocking function. Let's take a look at the code to see how this may happen. This is the code from my GitHub repo, and I will share the link of my GitHub repo in the video description. Here we define a blocking task, which uses blocking time.sleep for 5 seconds. Then we have async task 1, a coroutine, which invokes the blocking task. Because async task 1 is a coroutine, it has to run inside the event loop thread, and as it invokes the blocking task, the event loop thread gets blocked for 5 seconds. Then we have two normal coroutines, and in main function we are executing all three coroutines concurrently. Let's see what happens when we execute this code. Let's save this first. So task 1 starts, but no other task can start until this one completes. So as you see, task 2 and 3 only started when task 1 completed. So it overall took 7 seconds. What happens if we take out task 1? In that case, task 2 and 3 start and complete within 2 seconds. Yeah, so this is the effect of blocking tasks. If we are running into such issues, basic debugging can be done by enabling the debug mode in by passing the debug true to run function. And this will help us identifying where there is more than expected execution time occurring. So let's execute this once more. It takes once again 5 seconds, but because of this parameter debug true, we are now getting some information, debug information here, and it's telling that the coroutine async task 1 took 5 seconds to execute. So we know that there is some issue with the coroutine async task 1, and we can then look into it, and we find that, yeah, it's actually calling a blocking task, which takes 5 seconds to execute. All right. All the content related to this session is available on my website, atifazad.com. The article link is available in the video description. If you are interested, you can also find all the code in my GitHub repo. Thank you for watching, and I look forward to see you in module 2.